beam, the simply supported beam as shown over here. So the beam is supported at 2 points P and Q, and therefore the reactions are Rp and Rq at these particular points. Now it is subjected to the point loads of 15 Newton and 10 Newton as shown over here at a distance of 3 meter from the left hand support, then 3 meter further, and from the right hand support again it is subjected to the point load of 10 Newton. The space between these particular forces is given some notations, correct? And these notations are known as Gauss notation. So suppose this space is having the name A, this space is having name B, and this is the name C, and this is the name D. What does it mean that between this particular space, so 15 Newton is representative of AB, okay? BC is representative of this particular 10 Newton, you can say. CD is representative of this RQ, and DA is representative of this particular RP. So again, try to understand. So 15 Newton, correct, they are corresponding to this AB. 10 Newton corresponds to this BC. DC is related to this RQ, and DA is representing this particular RP. In other words, we have to find out the length CD and length AD, correct, on the vector diagram in such a way that we will get the values of RQ and RP respectively. So we'll take some scale, suitable scale for drawing these particular diagrams. So space diagram scale as shown over here, we have assumed 1 centimeter is equal to 1 meter. So this is 3 centimeter, this is 3 centimeter, and 3 centimeter representing 3 meters. Now as we have already seen, we have to start from this AB. The force is acting in the downward direction, and it is 15 Newton. The vector diagram scale we have assumed as 1 centimeter is equal to 5 Newton. So 15 divided by 5. So this is the 3 centimeter length representing AB, and that is the representation of 15 Newton force which is acting in the downward direction. Further, we are having the 10 Newton force also acting in the downward direction. So from this end point, again we'll draw the another vector in the downward direction. So total length will be this 3 plus 2, that is 5 centimeter, representing this 15 Newton force and 10 Newton force respectively. Now take any point O known as the pole in the space, and as we have already seen that this AB is 15 Newton force, and that we have represented by 3 centimeter, because 15 divided by 5, that is 3 centimeter, and this 10 divided by 5, that is the 10, that is a 2 centimeter. So BC is nothing but representing the 10 Newton force, and this AB is representing this 15 Newton force. We have chosen any point O known as the pole, and now we'll join this A with O, then B and O will join, and then C and O will join. So these are the rays which we have joined over, which we have obtained by joining A with O, B with O, and C with O. In the next step, what we'll do is that we'll draw a line parallel to this OA in the space of A. We'll draw a line parallel to this OB in the space of B, and then we'll draw a line parallel to this OC in the space C. So let us draw the first line. So this is a line which is parallel to OA in the space A. Then this is a line which is parallel to OB in the space B, and this is a line which is parallel to this ray OC in the space of C. Now we'll join this starting point and this end point by a dotted line, and then draw a line parallel to this line from O. Wherever it intersects this particular line, okay, that is your point D. So as we have already seen that this AD is representing this RP, and this CD or DC is representing RQ. So we can say that this AD length by scale will represent the reaction at P, that is RP, and DC by scale will represent the reaction at Q, that is RQ. So what we have to do, we have to measure this length AD and multiply by scale. So that we'll get the value of reaction at P. So measure this length AD. That length comes out to be nearly around 2.7 centimeter. Multiply by the scale. The scale that we have assumed for vector diagram is 5 Newton. So 2.7 into 5, that will be equal to 13.5 Newton. So we can say that reaction at point P is 13.5 Newton. Similarly, measure this length DC and multiply it by scale. So this DC is 2.3 centimeter multiplied by scale, that is 5 Newton, and we'll get the value 11.5 Newton. So in this way, we can find out graphically the reactions at P and Q, that is Rp and Rq respectively.